Okay, we're going to pretend that you are a designer for a big casino, designing a game you're calling the difference of two squares, or cubes, I guess. But at any rate, we roll these two cubes and we look at the difference of the numbers. In this case it's 3. We square that and that's 9. That's what the casino will pay out in winnings. If you roll doubles, of course, the difference is 0 and you pay out nothing. What is a fair or not fair when it comes to casinos? What would be an appropriate amount for a casino to charge to play this game? If you are designing this game for a casino, what would you charge? Cheap enough to lure in the players, but not too good so that you lose money. Alright, that's the question. Okay, so we're looking at this game that we're calling the difference of two squares, and we're trying to find the expected value for that game so we know what a reasonable fee to charge would be to play it. With expected value, it's all about breaking things down into their individual outcomes and then multiplying the probability for that outcome times the value of that outcome. So what we need is to really look at all of the possible ways that two dice can be rolled. So I need to do some of my magic again and make this appear. So, hey, there we go. Alright, so if we look at all of the different outcomes related to the difference of these two dice, you'll see that down the middle here, these are all of the outcomes where the difference is equal to 0. And these are all of the outcomes where the difference here, and then this one, where the difference is equal to 1. There's 6 of them for this one. There are 5 and 5. That makes 10 for a difference of 1. For a difference of 2 then, that's going to be 4 plus 4 will be 8. A difference of 3 units will be 3 and 3 is 6. And then you got the pattern by now. For 4 it's 4 because it's going to be 2, and then these 2 of course. And then finally 6 and 1 and 1 and 6 are the only ones that'll have a difference of 5, and there are just 2 ways for that to happen. So as you know, it should total up to 36, and it does. So these are the number of ways that the events can happen. The probability then would be all of these would be out of 36, and I guess what I can do is most easily express that as a fraction. I'm going to get rid of this bracket here. The fraction then for each of these would be 6 out of 36, which is 1/6. That's the probability that my dice are doubles. This would be 10 out of 36, or 5 out of 18. This would be 8 out of 36, and that's going to be 4 out of 18, or 2 out of 9. This would be then 1/6 again, and this would be 2/9, and then finally this would be just 1/18. So these are the probabilities of each one of these events happening. Now, with expected value, it's all about the probability of a particular event multiplied by its value. So the value of this would be 5 squared would be 25. 4 squared would be 16. 3 squared would be 9. 2 squared would be 4. 1 squared is 1, and 0 squared is 0. So to find the expected value of any one of these, I just simply multiply the probability times the value. So I'm going to pause it, come back, and I'll tell you what those are. Okay, I'm back. I've crunched the numbers here. It's pretty straightforward. The probability of each of our possible outcomes is multiplied by the value. You get that for each of those outcomes, the individual values. You total them all up. Turns out that per turn, the total expected value of this game is about $5.83, so $5.84. A casino then you'd expect to charge like around $6, or some of them are, 7 or 8, but $6 would be just that thin razor difference that would make all the profit for the casino in the long run. When you play this over and over again, it's going to generate 17 cents per turn per player. It may seem as though you've got some bigger payouts, $9, $16, $25, but they don't happen frequently enough to make it worth it. Okay? So in the book they look at expected values of things like insurance, where you might get one house that needs to be replaced out of every 200,000 homeowners. Then you'll get more individual, like little problems with floods or smaller things where you pay out lesser amounts. The way an insurance company works it out is they think of all of the possible scenarios and all of the possible payments they have to pay out. And then by dividing that by the total number of participants in an insurance plan, you can get sort of an expected value per plan, and that's how they'll set insurance rates. So read through the book, prep for class, and we'll see you soon.